Hello friends, in today's question, 2 point masses of 0.3 kg and 0.7 kg are fixed at the end of the rod of length 1.4 meter and of negligible mass. The rod is set rotating about an axis perpendicular to its length with a uniform angular speed. The point on the rod through which the axis should pass in order that the work done required for the rotation of the rod is minimum is located at a distance of. So we have to find out the point through which the axis is going to rotate so that the work done is minimum. So we are given that there are 2 point masses. Let us suppose this is M1, which is 0.3 kg, and we have M2, this is 0.7 kg, and the distance between the two is given as 1.4 meter, and it is given we are supposed to find out the point of rotation where the work done is minimum. So we assume that this be the point about which this rod is rotating with a uniform angular speed, that is omega, and it is at a distance of x from M1. So from M2 it will be 1.4 minus x. So we have to find out value of x either from M1 or from M2. Okay, we have to find out this point. Let us suppose this point is P, its value from M1 or its value from distance from M1 or distance from M2. So in order to solve this, we are going to use work energy theorem. Work energy theorem. And work energy theorem states that net work done by all the forces, net work done by all the forces on an object will be equal to change in the kinetic energy, will be equal to change in kinetic energy. Now the kinetic energy is dependent upon moment of inertia as well as angular velocity of the rod. So kinetic energy is dependent on moment of inertia and angular velocity of the rod. Now herein the question itself, it is given that the rod is rotating with a uniform angular speed. So you can say given that angular speed is constant, angular speed is constant, therefore the kinetic energy will be only dependent upon moment of inertia. Therefore kinetic energy only depends on moment of inertia, or we can say that work done is now only dependent upon moment of inertia. So work done depends only on moment of inertia, and in the question it is asked that the work done should be minimum. So for the work done should be minimum, the moment of inertia should be minimum, or we can say that work done will be minimum when moment of inertia is minimum. Therefore, let us find out the moment of inertia and so we can say inertia about point O will be equal to inertia because of m1 whose distance is x square plus inertia because of second mass, that is m2, and whose distance is 1.4 minus x and whole square. So for I to be minimum, when, or we can say di upon dx should be equal to 0. So we are going to simply derivate the equation. D of dx, and we get this as 0.3x square plus 0.7, and this is 1.4 minus x whole square is equal to 0. So in order to derivate, we are going to get this as 0.6 x plus this will be equal to 0.7 multiplied by 2, and this will be 1.4 minus x, and minus 1 is equal to 0. So we can write this equation as 0.6x minus 1.96 plus 1.4x equal to 0. So here we get as 2x will be equal to 1.96, or we get x will be equal to 0.98 meters. And we know that x is a distance from m1. So therefore, the axis of rotation should be at a distance x is equal to 0.98 meter from m1, and m1 was given as 0.3 kg. So the axis of rotation should be at a distance from mass m1. So this completes the question. Thank you.